Now we are heading towards the another lecture on operations on signal convolution. The convolution of two signals in the same the time domain is equivalent to the multiplication of the representation in frequency domain. So, what is convolution? The convolution is of two signals in the time domain is equivalent to the multiplication of their representation in frequency domain. That means if we find out that is represented in the time domain, y2 is equal to x1t, that is convolution sign into x to t. So mathematically you can write the convolution of two signals as like that, but in frequency domain when you see that that is the time domain sequence. So after doing frequency domain shift like that, if we take that is y in t, that will be k, so that will be yk, so that will be x1 k or n, whatever else it might be, into x2 k. So that will be the representation after convolution. Okay, now we will find it out. So first of all, in convolution sequence, so when you convolve like that, the mathematical expression of convolution is like that. That is integration of the concatenation. That means the integration, that is the limit minus infinity plus infinity. It can be changed due to your sequences that you have taken. So there is another variable p that you are integrating the total sequence, the multiplication of the total sequence. So replace the t with p here and x2 with t minus p. That means the p shift, that is t minus p, that means that is a delay. Okay, it's a p shift, and that will be integrated with dp with respect to p. Now steps for convolution. First of all, take signal x1t and put t is equal to p, so that it will be x1p, so that will be x1p. Take the signal x2t and do the step 1, make it x2p. That means we have to first of all take the function as p, okay, replacing t as p, and make the folding of the signal as x2 minus p. Folding means here we can see that t minus p is there. So folding such that means that the folding property means to take the inverse of a function, okay, with respect to its x-axis. That means with independent variable. Okay, so x2 minus p here. Now do the time shifting of the above signal. That means minus p minus t. As you can see here, t minus p is there, x2. So we are just looking forward to the time shifting property. Okay, minus p, that's minus p, just we shift the t minus t here, extra time shifting. Then do the multiplication of both signals like that, x1p into x2 minus, that is the minus, the folding, total folding, this p minus t is here. Now after taking this, we get the convolution. Integrating the total sequence, we will get the convolution. Now first of all, there is an example of let us do the convolution of a step signal ut. So that is a step signal ut with its own kind. That means that is the same ut signal we want to convolve. So then we have to take up, that u minus p minus t dp. So t can be greater than or less than 0, which are shown below figures. Okay, now we will heading towards our next figures. Just you can see here, that is the figure. That is the figure. Yes, that is the figure. That's the step signal figure. As you can see here, it's the step signal figure up. Step signal means the value is 1, and step means that is a staircase type, and minus p means folding. The x-axis will be negative, and it goes into that position, and then we go to the shifting property. That means t times shifting, minus p minus t, just shift there, and that is t less than 0. If we shift in the positive direction, that will be t is greater than 0. So with the above case, the result arises with following possibilities. That is, yt is equal to 0, 0 to t, 1 to t. 1 means that the value of unit step, that is unit. So the value of the function is 1, and the dt, and if t is greater than 0, and if t is less than 0, that will be 0, because that is the unique, what can I say, that is the property of unit step function. So now you can take this, and for this, after integrating, you get the result like that, that is 0 if t is less than 0, and if it is if you just integrate this, you will get t here, t with t is greater than 0, and that is the function of rt here. So that is the properties of the convolutions. There are some properties of the convolutions. That is the commutative property. The commutative property, it states that the order of convolution does not matter, which can be shown mathematically as. That means the order can be exchangeable. It's x1, x2, and that has been exchanged, but it will not change any kind of results that you find. The second property is the associative property. The associative property means that it states that the order of convolution involving 3 signals can be anything. Mathematically it can be just like this. Order can be order of convolution of 3 signals means that is the order of x1t convolution of x2t convolution of x3t, and this pair has been just separated by a bracket. So just transfer or shift the bracket from here and there, that will not change any other results in convolution. So it's also a type of property here. Now there is another property, that is distributive property. 2 signals can be added first, and then their convolution can be made to the third signal. This is equivalent to convolution of 2 signals individually with third signal added finally. Mathematically it can be written as, that is distributive property. That means when you convolve with the addition one, so addition or subtraction. So that is the bracket here, you can see the addition one. So each of the additions will be convolving distributively. Okay, that you can say that each of the signals can be convolved separately, but the plus operation is still there. There is an area, if a signal is the result of convolution of 2 signals, then the area of the signal is the multiplication of those individual signals. As you can see, if we take the area here, just that will be the multiplication of that area. Okay, so that is the convolution property again. Some scaling properties, if 2 signals are scaled to some unknown constant a and convolution is done, then resultant signal will also be convoluted to some constant a and will be divided by the quantity as shown below. As you can see here, if we take scaling property means if we take any kind of constant value or any kind of value multiplied with the independent variable, if we take this, so that will be the that will be the output of that. As you can see that scaling property is there, the output will be yat. That means the independent variable has taken the scaling factor there, but by the divided one, the divided quantity will be there, whether the a not equal to 0. Now there is a delay property. As you can see, suppose a signal yt is a result from the convolution of 2 signals x1t and x2t. If the 2 signals are delayed by time t1, as you can see they are delayed by time t1, so the output will be that is t1 delay and t2 delay here. This t delay is here, t minus t1, t minus t2. So we can write it here yt minus t1 plus t2. The total delay will be, the resultant signal yt will be delayed by t1 plus t2, and that is another property of convolution. So as we can see there are different type of convolution properties in convolution. So thank you very much for being with me in this lecture.